Okay, so in my previous video, took a look at automation in physics in the context of converting between units with prefixes. Now, I wanted to make a second one looking at this same automation process, but in terms of rearranging equations. So, what are we trying to get out of this video? Well, I want you to know why we would want to automate these processes. I want you to know what you would need to know before we can automate using equations. And then finally, we're going to look at the process we will use every single time we're handling equations so that it can become automatic. So, in terms of what I mean by automation, I briefly looked at this in my previous video, but in case you haven't looked at that, what we mean is getting to the point where we can do something without conscious thought. And we do that by following the same process every single time we're trying to do something. So in this video, we're going to look at automating rearranging equations. So what we're going to do is we're going to use the same process every single time we want to rearrange an equation. That's how we can automate it. So why would we want to do that? Well, in one of my previous videos, I looked at the working memory, or essentially the number of spaces you have in your brain or in your head to handle or juggle information. And if we have something on autopilot, it doesn't occupy one of those spaces, which is what makes this so useful. And it frees up space for the problem solving and logical thinking stuff that is so important in physics. So, what do we need to know in order to be able to automate this equation rearranging processes? Well, we have to know the mathematical operators, and we have to know which ones are inverses of each other. Okay, so that's what I've done here on the left-hand side. I've just got a table of an operator and its inverse. And so let's have a look. So what this table is saying is the opposite of multiplying is dividing. And that we can also use the same logic in reverse. So the opposite of dividing is multiplying. So the inverse, or the opposite of adding, is subtracting, and that works the other way around as well. And the opposite of squaring is square rooting, and that works the other way around. I could have continued and done the opposite of cubing is cube rooting, and etc. etc. But hopefully that all makes sense. One I've stuck in there that most of you won't come across, at least until you get to A level or pre-U kind of level, is we start introducing a new operator, the exponential function, and the opposite of that would be the logarithm. So we can still use the same tools, however complicated all the equations become. As long as we know something's inverse, we can follow the process that I'm going to show you. So, what does that actually look like, and what does an inverse actually mean? Well, inverses will essentially undo the effects of the first operator. So if we have a look in here on the left-hand side, so if we multiply 5 by 6, we get 30. So the opposite of multiplying by 6 is dividing by 6. So if we take 30, we divide by 6, you can see we've got back to the original thing. So we've essentially undone what we just did. That's what an inverse does. We do the same thing. So if we do 7 minus 2, that gives us 5. So if we do 5 plus 2, which is the opposite of minusing 2, we get back to 7. So again, we've got back to our original number. That's the role of the inverse, and that's going to be useful when we're rearranging equations, this idea of undoing operators. Okay, so that's the first thing that we need to know and have committed to our memory. And I've shown you in several videos some strategies that I use to actually commit information to memory. Next thing we need committed to memory is the order in which operations take place. So you should have learned about this in maths. It's often called bid maths or bod maths, depending on what your teacher prefers, probably. So whichever way you do it, these are both communicating the same thing. So they're telling you the order in which a calculation should be carried out. And we need to know this in order to be able to deal with equations or automate those processes. So the first thing we do is brackets, then we deal with powers or indices or orders, whatever you want to call them. Then we do division, then we do multiplication, then we do addition, then we do subtraction. Now, actually, in reality, these two, it doesn't really matter. These two, it doesn't really matter which order you do them. But this is the classic way that you're taught to do them. So if you have a calculation like over here on the right-hand side, so we're trying to calculate what x is, and we've got a whole sequence of operators. So the first thing that BidMass tells us how to do is deal with the brackets. So there we go, 6 plus 4, we can now replace 10. We've now got rid of our brackets. Next, we should do powers. Well, there aren't any, so we can forget about that. Then we do division. So we're going to do this 5 divided by 2 first of all. So you can see we've got 2.5. Then we do multiplication. So we're going to do 2.5 times 10. Then we do addition. So we've added the 1 to get 26. Then we do subtraction and we've got 24. Now, you should realize that we could have done stages 2 and 3 in either order, and we could have done stages 4 and 5 in either order, which is what I was referring to earlier. But that's our process for ordering, and we're going to need that as part of our automation process for rearranging equations. Okay, so is our automation process. We're going to do the same 3 things every time we want to rearrange equation. We're going to identify the quantity we want to calculate. We're going to see what operators are currently applied to that quantity. And then we're going to apply the inverse of those operators in reverse BidMass order. So those are the same 3 things we're going to do every single time. So let's see some examples of this at work. So what we want to do is calculate the acceleration of an object using resultant force and mass. So this stage 1, what do we want to calculate? Well, we want to calculate acceleration. So we've done stage 1. So then we always do is actually figure out what our equation is. So our equation linking these 3 things is F equals ma. So what operators are currently being applied to that quantity? So looking at acceleration, we can see it's currently being multiplied by mass. We can see that in the equation. Okay, fine. So what we're going to do is the opposite of that. So we're going to divide both sides by mass, because that's the opposite of multiplying by mass. So when we do that, we're going to have on the left-hand side force divided by mass, which is what you can see down here on the bottom left. We've got force divided by mass. We're going to do the same thing on the right-hand side. So we're going to take mass times acceleration, and we're going to divide it by mass. And what you'll notice is the m's cancel out, and you get left with acceleration. So what we've got now is our equation that we need to calculate our acceleration. We're going to put in the resultant force, and we're going to divide it by mass, and that will give us the acceleration. And that's just applying those 3 things. So this one was easy because we only had one operator, so we didn't need to worry about the order in which we did things, right? Because we only had one thing happening. Let's actually see where the order is important. We want to calculate the acceleration of an object using v equals u plus at. So the quantity you want to calculate, well, it's acceleration. So you can see in our equation that it's here. So what do? What is currently being applied to that quantity? Well, currently the acceleration is being multiplied by time and it's being added to the initial velocity. That's what we can see in the equation. So we're going to do the opposite of those 2 things, but the order in which we do that is important. So we're going to do it in reverse BidMass order. So the first thing we're going to look is subtraction happening. Then the S. No, it's not. So we don't have to worry about that. Is addition happening? Yes, it is. So what we're going to do? We're going to do the opposite of that. So we're going to subtract the initial velocity from both sides. So we get v minus u is equal to at. Okay, so we're going to check multiplying. Is any multiplying happening? Yes, it is. So we're going to do the opposite of that. We're going to divide both sides by the thing. So we're going to divide both sides by t. So we get v minus u over t, because we need everything on the left-hand side divided by t. And we get the right-hand side divided by t as well. And again, the t's cancel out. So this is why we're using the inverse. It's going to make these things cancel out every time. So you get an equation for acceleration. So if we want the acceleration, we're going to need the final velocity minus the initial velocity, all divided by t. So we notice here we can forget about the d, I, and b because none of those are involved in here. Let's look at another example before we actually see some with numbers in it. So calculate the initial velocity of an object using v squared equals u squared plus 2s. So we've got lots of things going into here. So first of all, what do we want to calculate? We want to calculate the initial velocity, which is this, the u in our equation. That's what we want to find. So stating our equation. So then we ask ourselves, what is currently being applied to that quantity? Well, currently the initial velocity is being squared, and it's being added to 2as. So a is acceleration and s is displacement, but that doesn't matter too much for this example. Okay, so what do we want to do? Well, if we go through, is any subtraction happening? No, it isn't, so we can not worry about that. Is any addition happening? Yes, it is. So we're going to subtract 2as from both sides. So we've taken care of any additions that were happening. Is any multiplication happening? No, it's not. Is any division happening? No, it's not. Are any powers being applied? Yes, they are. It's being squared. So what we're going to do is we're going to square root both sides. And we're going to square root everything on both sides. So square root of v squared minus 2as and square root of u squared, which is u. Technically it's plus or minus u, but we won't get into that for now. And what we've done is we've made u the subject here. So we could now plug in values for v, a, and s, and we could calculate what u is. And so we've taken care of power. There aren't any brackets, so we've done that. We've applied bid mass in reverse order. Okay, so what I've been trying to highlight there is the kind of the process I'm going through. So what I'm going to do is take away all the stuff in purple to show you what my working would actually look like in some real examples with numbers. Right, so here's our question. Calculate the speed an object has to travel at to stay in circular motion if it experiences a resultant force of 20 newtons, the radius of its circular path is 5 meters, and its mass is 2.5 kilograms. So, you may or may not know the equation for this, but I do. The equation that we need is F equals mv squared over r. And what the equation is of no importance here apart from the fact we want the correct answer. So let's go through our process. What are we trying to do? We're trying to calculate the speed. We can see it in here. So if we start thinking through our process, what we're trying to do is calculate this v inside this equation. So the stages we're going to go through is we're going to apply the inverse operators in reverse bid mass order. So let's look at what's actually currently happening to v. You can see it's being multiplied by m, it's being divided by r, and it's being squared. Okay, so those are what's currently happening. So what I'm going to do is go, okay, so is anything being subtracted? Nope. Is anything being added? No. Is anything being multiplied? Yes, it is. So what we're going to do is we're going to do the opposite. So it's being multiplied by m, so I'm going to divide both sides by m. So we get f over m is equal to v squared over r. Okay, so we've dealt with multiplication. Is anything being divided? Well, yes, it is. So what we're going to do is we're going to do the opposite of that. Okay, so we're going to multiply both sides by r. So we're going to get fr over m is equal to v squared over r. So just incidentally, I could have written that as f over m times by r. That would have been exactly the same. It's not equal to v squared over r. What am I doing? I've just got rid of the r. And we get an expression like this. But those two expressions are identical to each other, which is why I'm not writing that. I'm just writing it as you can see. Okay, so then finally we go, okay, so we've done division. Do we have any powers? Well, yes, we do. We have squaring. So what are we going to do? We are going to square root. We're going to do the opposite of that. So we're going to square root everything on the left-hand side, and we're going to get our expression equal to v. So now we've got the equation that we need to actually do the calculation. So let's now actually plug some values in. So if we want to calculate v, we're going to need to do some square rooting, and we're going to need to square root 20 times by 5 divided by 2.5. Okay, so what we need to do is get our calculator and actually figure out what that is. We'll bin that. We don't need to actually bother calculating what the value is because it doesn't really matter because it's a made-up question. So let's have a look at a second one. So again, you can see this process in action. So we want to calculate the speed an object is traveling. It falls 15 meters on Earth, and it was initially stationary. So this is a classic conservation of energy question. So the initial GP, if you like, is going to be equal to the final kinetic energy. So we can see that mgh is going to be equal to half mv squared. Okay, so that's our setting up. And you can see if we look in the question, the thing we want to calculate is the speed. So we want to find out what v is in here. That's what we're trying to solve. So a stage of our process that we didn't mention, but it's worth mentioning, is noticing, let's make our question simpler. So straight off, let's cancel out our m, because we don't need to be dealing with anything extra in here. Okay, so then we go, okay, so let's write out our bid mass. And we're trying to get to v. So what's currently happening to v? Well, it's being squared, and it's being times by a half, or being divided. We could have equally said it's being divided by 2. Those two are the same thing. Okay, so going through order, is it being subtracted? No, it isn't. Is there anything being added? No, there isn't. Is there anything being multiplied? Well, I think there is. We're being multiplied by a half. So what we're going to do is we're going to divide by a half, or we're going to times by 2, however you want to think of it. So we're going to have 2gh is equal to v squared. So we've dealt with multiplying. Is there anything being divided? No, there's not. Are there any powers? Yes, there are. So let's do the opposite. We're going to square root. So we're going to end up with square root of 2gh is equal to v. And we've now got an expression where we've made v the subject. So again, what we can do is we can go, okay, well, if we want to calculate v, we need to do the square root of everything. So we're going to do 2. We're on Earth, so I'm going to use g equals 10. We could be more precise and use 9.81, but whatever. And then we can see the decrease in height is 15, and then that will give us some kind of answer, which I don't care about. Okay, so if we reflect back on what we're trying to achieve here, so we want to know why we want to automate things in terms of thinking about freeing up our working memory. So that's why we want to do this. We need to think about what we need to know before we can do this. So in this context, we need to know what the opposite or inverse of operators is, and we need to know the order in which operations are done. Those are the two things we just have to know and have in our long-term memory. Then finally, we need to know our automation process. So we're scanning to look at what we're trying to calculate. We're then looking in our equation at the operators currently acting on the thing we want to calculate. Then we do the opposite to those operators in reverse bid mass order. Okay, so that's the process, and by using that process over and over and over again, that will become automatic and we won't have to think about it. So how are you going to actually achieve that? Because as I said, we need to do some repetition here, get this process automatic in our brain. So the is Isaac Physics. So I am in no way affiliated with this. I just really like it. I think it's really good. So if you get onto www.isaacphysics.org, get yourself signed up if you haven't already. And the section you're almost certainly going to want is this GCSE. And then what we're going to do is you want this section here. You want the physics skills mastery. You want to just go into general skills. So this section right here. You're going to want, for this particular one, you're going to want this rearranging equations section. So it just gives you some practice. It will give you an equation and it will ask you to rearrange it to make various things the subject. So it's a chance to put the processes we've done into practice. So you've done it a few times over and over again. And then once you've done that, you'll actually be in a position to apply it to some real physics equations. But the thing you have to really make sure you're doing is a process using that same process every single time. And by doing that, it will become automatic and it won't take up space in your long-term memory.